Hi, I'm here trying to get you ready for your final exam, your midterm. Let's see how it goes. As you can see, what I have is my little geometry packet with a protractor, ruler, compass, pencil, eraser, right out of the pack. Let's take a look at the first question. It says, write in words. And it says this. Well, I know that if it doesn't have any arrowheads on it, it's called a segment. And if it does have one, then it's a ray. So basically this needs to say segment PQ is perpendicular, because see, that looks like a 90-degree angle there. So that's perpendicular to ray RS. So here it goes. The segment PQ is perpendicular to ray RS. And there you go. Next, write a notation. Line XY is parallel to ray QR. Okay, line means two arrowheads, so it's going to look like this. And parallel looks like this. And ray QR will look like this. Piece of cake. Okay, next. Here, let's look at this one. Construct angle PQR at 70 degrees. Alright, so what I'm going to do is I'm going to first make a ray. And then I'm going to use the endpoint as a vertex. And I'm going to measure 70 degrees away for the other part of the angle. So what I do is I line the protractor up with the ray. And I make a mark at 70 degrees, which is over here, and then I construct the angle. So it looks like that, and it's 70 degrees. I need to call it angle PQR, which means this one can be P, this one's definitely Q, and this one can be R. If I had to classify it, well, I know that it is less than 90 degrees because it's 70, so the word for angles that are less than 90 degrees is acute. So it is an acute angle. And then the vertex is point Q. And the sides, something that people have trouble with, the sides will be ray QP and ray QR. So it looks like this, ray QP and ray QR. Those are the sides of the angle. Okay, next. Here we have this five-sided figure, and we have to find X and Y. Well, first of all, it's a five-sided figure, 1, 2, 3, 4, 5, and that means it's a pentagon. The sum of the interior angles. Well, if it has 5 sides, you can find the sum of the interior angles with the old n minus 2 times 180 trick, which should read 180, not 1880. Sorry about that. Alright, so 5 minus 2 is 3. 3 times 180 is 540. So it's 540 degrees. That's what it all adds up to. So, let's figure out what this is. Well, what we have here is a linear pair, so then this one has to be 130. So then 130 plus 120 is 250, plus 50 is 300, plus 170 is 470, so 540 minus 470 is 70, so X is 70, and Y is its linear pair, so if this is 70, this has to be 110. So Y is 110. Not so bad. Okay. In the next one, I believe we have to say something is parallel to something else. Well, let's say that line A is parallel to line B. Now, we kind of made a mistake here. Nothing was filled out. So let me just do a for instance. We'll do 1 and 5. If you look at 1 and 5, those are classic corresponding angles. If we look at, let's do 4 and 6. Let's try 4 and 6. Your paper may say something else, but it's worth knowing anything. So 4 and 6, here they are both inside the parallel lines, same side of the transversal. That makes them same side interior. Same side interior, because of the same side of the parallel lines, same side of the transversal inside the parallel lines. Next, let's try 3 and 2. So look in 3 and 2 here. Well, they're in the same intersection. They're across from each other, so that's easy to remember. That's called vertical angles. Okay, next one, another for instance. Let's say if measure of angle 5 equals 107 degrees, find measure of angle 3, 4, 7, and 8. We'll try that out. Okay, so if 5 equals 107, then we know that this one will also be 107 by vertical angles. That would make this one 73, 73 here. Then you just jump with your corresponding angles, and everything is pretty easy to figure out. So there we've got everything. So again, if 5 is 107 degrees, find the measure of angle 3, well, that'll be 73 degrees. Find the measure of angle 4, that will be 107 degrees. Find the measure of angle 7, that'll be 73 degrees. Find the measure of angle 8, that'll be 107 degrees. Alright, there we go. Next, construct a perpendicular bisector CD intersecting AB at E. Alright, perpendicular bisector. See if I can do this one-handed. First we make an arc. Let's see. And then we make another arc. And then we use a straight edge to connect the arcs. So, it looks something like this. Okay. So this perpendicular bisector needs to intersect at point E, so then that'll be point E. Now construct an angle bisector EF bisecting angle AEC. So again, this has to be C up here, D is over here. So now I need to do an angle bisector. So I'm going to do an angle bisector of angle AEC. So I'm going to do my angle bisector over here. What we should realize is that a perpendicular bisector means that this will be a 90-degree angle. So that's something to think about. Alright, so now I'm going to try to do my little angle bisector. It's very tricky one-handed. Let's see. Okay, there's an arc. Now we go to the location of that arc to make the next arc. We go to the other end of the first arc to make this arc, which must be congruent. And then, if you look at this intersection, we line up to that intersection and finish the construction. And bisecting that angle, so we should end up with F here, and the measure of angle AEF should be 45 degrees. Which it most likely is. Let's just take a look, see how accurate this one-handed construction was. Measure of angle AEF is right here. Yeah, look at that. Pretty darn close to 45 degrees. Not bad at all. Alright, cool. Next, we need to find A and P of this parallelogram. Seems kind of hidden. First thing I noticed though is there's a right triangle built in here, so basically I think I can find this distance. So that's going to work like this. 6 squared plus 8 squared equals x squared. That's 36 plus 64 equals x squared. That's 100 equals x squared. That's x equals 10. Alright, so now this is 10. By the way, anyone know how far this is? You're right, it's 14. This has to be 10 also, and up here is 14 also. So now the area is going to be the base times the height. What you got to realize is that base means this distance. So how long is this? 14. The height is this distance, so that's 8. So basically we're doing 14 times 8. Well, 14 times 8. 8 times 4 is 32. 8 times 1 is 8, plus 3 is 11, so the area is 112 units squared. The perimeter, we just add up all the sides. So this side is 14, this side is 10, that's 24. Plus 14 is 38, plus another 10 is 48 units. Alright. Not so bad at all. Alright, next one.